So let's look at the theorem of parallel axes formula then. Here it is here. The second moment of area IXY about XY, IXY is equal to the second moment of area about this line parallel to it, which passes through the centroid or the centre of gravity of the uniform lamina, plus the area of the shape times h squared. The distance between these two axes, the parallel distance perpendicular to both, h squared. So that's the formula then, so we'll use that formula to get these answers below then. So just remember this, ig plus ah squared is ixy. Okay, with that in mind then, let's have a look at these. Remember it's a 12th AB squared, isn't it, for a rectangle? This goes through the middle, so it's the normal formula 1/12 A, which is the side parallel, which is 6, times b cubed rather, wasn't it? So it would be 4 cubed. 12th AB cubed. So 6 over 12 is 2. 4 cubed, 64 over 2 is 32. Okay, next one then. So this one IPQ here. Okay, well we know that it will be this through the centroid IG. So that would be 32 plus area, 24, 6 fours are 24, times the distance here, squared, AH squared, which is 4 24s, which is 96, 98, 128. Next one. Here, there's the parallel axis through IG. We know that's 32. Plus A, which is 24, times the distance here, which is 6. So it's 6 squared, AH squared. Type that in a calculator then, and we end up with 896. Next one is going to be just the 32, but in this time it's 24 times 8 plus 2 is 10 squared. So it's 2432, isn't it? 2400, 2432. Okay, that's that done then. So it's quite simple to use, isn't it? Let's look at the next example, IPQ here. We've got A and B. So IG is 1/12 AB cubed plus that distance has B over 2. So it's the area, AB, times the distance between these two squared, which is B over 2 squared. So that's equal to then 1/12 AB cubed plus AB cubed over 4. And that's 3/12, so it's 4/12 is a third. AB cubed over 3. Next one. So here IAB, here, well, the parallel would be 1/12 A. So A would be 6 times B, 4 cubed. Okay, 6. Oh, hang on, plus, that would be IG, plus A, 24, times H, oops, which is 2 squared. That's a 2, 32 then, plus 96, 128. Okay, and then IAC here. Well, if we look at this one then, this parallel through G here, this would be 1/12 of A, 4 times 6 cubed, plus A, 24, times H, which is 3 squared. 36 times 2 is 72, plus 27 times 24, I think. No, it's not quite right, I don't think. What was it? What was the fraction? It was plus AB squared, wasn't it? Yeah, AH squared. So it's 24 times the H distance, which is 3 squared. Oh, that's 9, sorry. That's why I was way out there. I'm worried about the answer. That's just 9 24s. 180, 216, 218, 288. It's better. Okay, that's example 8. Now example 9, which looks a bit tricky, but let's have a look at it. We want IAB and IEF. So IAB. Okay. So A to B is across here. Would be I of this first thing here. So I of that would be I of this, which would be 112. For this rectangle and this parallel axis, it would be 112. A is 3, and B was 1. AB cubed plus, so that was the second moment of area about the centroid, plus A, which is 3 times 1, times the distance squared between the two parallel axes. So this axis and that one is a distance of a half squared, and the area is 3 times 1 is 3. So what have we got? We got 1/4 plus 3/4 is 1. So that's 1 for that one, as far as I can see. Now the second shape would be this one, and we could take an axis here, there, and the I of that would be 1/12 A, which is 1, times B 2 cubed. So that would be that. The I about that axis, AB cubed, plus area, which is 2 times 1, which is 2, times the distance squared. That's a 1 and that's a 1, so it's 2 squared. So that would be 8/12 is 2/3 plus 8 and 2/3. So that was 8 and 2/3. So that was, sorry, that was 1 for this segment 1. We're not doing EF yet. So it would be plus this amount. This plus this. So we got 1 and 2/3. So I better write it out a bit better than that, hadn't I? So it'd be 9 and 2/3 would be the final answer. So it's 9 and 2/3 when you add the 1 to it. So let's just put it together then. Okay, and the answer when you tap it all in, simplify it as 9 and 2/3. And that was IAB. Remember we did this area and this area, and we worked out the second moment for this one using the parallel axes theorem, and the second moment for this one, and we just added them up, 8 and 2/3 and 1. 1 and 8 and 2/3 is 9 and 2/3. Let's do the next one. IEF then. Well, we can do the same down here, can't we? It would be that one, which we've just said is 2/3 for this axis here, because we worked that out here, for this shape here. So that's 2/3 plus A, 2, times H, which is 1 squared, 2 and 2/3. Plus, now that was that area, and then we got plus this area here, which was that one, which we know from before is this, which is a quarter, plus the A, which is 3, times H, which is 2.5, or 5/2 squared. So equals quarter, 5/4, 15/4, 16/4. 16/4 is 4. So we've got 25, 12/4. 25, oh, hang on a minute. 25/4 times 3 is 75/4. 76/4 is 76/4, which is 19. So that equals then 21 2/3. That's the answer. So I hope you saw that for example 9. Okay, so ICD here, will it be this shape and that shape added together? So the I through the centroid here, parallel axis through the centroid, is going to be this formula here, which is 1/36. A, which is the base, which is 4, times the height 6 cubed, plus, that was I through the centroid, which is 1/3 of the distance up from the base, or h/3. So that's 2 units up, so it would be plus 1. What was the formula again? Plus AH². So the area would be half base, half of 4 times 6. That's the area, times the distance AH², which is 2 squared. That's it. So that would be for the triangle then. That's the area times the distance between these two parallel things, and that's 1/3 of the base up, which is 2 units, and that's through the centroid. That was the second moment of area through the centroid, and then you have AH² to it. You add that. That's for that shape. Plus this one through the centroid then is this formula 1/12. A, which is 4, times B, which is 6 cubed, plus A, which is 24, 6 4s are 24, times H3 squared. So that should be the formula. So let's see what we get. 6 4s, because 2 of them will cancel, 24. That one will cancel. We'll have 2 6s are 12 times 48. Here, this will be 3. One of these, and there'll be a 2 left, won't there? 36, 72, and 9 24s. 9 4s are 36, and 9 20s 180, so that's 216. 48, 50, 120. 336, 340, 360 is the second moment of area for that shape, about CD. IXY then, let's have a look at this one. Well, I'll leave that for you to do, but adopting the same principles, because time's running out, it'll be 1080, and hopefully you'll be able to work that one out as well. The same approach as what we had here.